So in this video, I'm going to go over how to solve problems over exponential functions that will help you get ready for the STAAR test. So exponential equations, remember, have the form y equals a times b to the x, where a is the initial value and b is the rate of change. Remember, when b is bigger than 1, this equation represents growth, and when b is less than 1, this represents decay. So another issue you can have is if the growth and decay rates are given to you as percentages. Okay, this is very important. If the word problem says percentages, you'll use this form of the equation. Instead of b, we have 1 plus r, or we have 1 minus r, and that's going to be used to calculate the growth rate when we have the situation where there's percentages. Remember that r is going to be the percentage as a decimal, so you'll have to convert it to a decimal before you plug into these problems. Another kind of problem you can see is how to calculate exponential regressions. So if it gives you a table of data, you'll have to enter that table into L1 and L2 in your calculator. So remember, you can find this by going to Stat and then clicking Enter on Edit. Then in L1 and L2, you enter the table of values, and then you click Stat, arrow to calculate, and you'll choose option 0, which is exponential regression, to get an exponential equation for your table of values. Then you're going to hit enter on calculate, and it'll give you the equation, which you'll write as 6.75 times 1.16 to the x. So remember, since this growth rate is bigger than 1, this represents exponential growth. So let's look at this first problem. It says a bank account earning annual compound interest was opened, and no additional deposits or withdrawals are made after the initial deposit. The balance in the account after X years can be modeled by B of X equals 850 times 1.25 to the X. So what is the best interpretation of the values in this function? So let's look at this. So this is B of X equals 850 times 1.025 to the X. So remember that this has the form A times B to the X. So A is the initial value, and B is the growth rate. Remember, it's a growth because it's bigger than 1, so it's going to be a growth rate. So F says the initial value decreases at a rate of 97.5% a year. That's incorrect because the rate shows you that it's going to be increasing. G says the balance increases at a rate of 2.5% each year, so let's check whether that's correct. So remember, 2.5%, since it's a percentage, we have to turn this into 1 plus R, so 1 plus 0.025 by moving the decimal to the left twice, so that'll be 1.025 to the x. So that seems to be correct. H says the initial balance was 1025. That's incorrect because the initial balance is 850. And it says the balance in the account at the end of 1 year is 850. Let's see whether that's correct. So that means that 850, which is our balance, should equal 850 times 1.025 to the first power, because that means after 1 year. Well, when we plug that in, we get 850 equals 850 times 1.025, and 850 does not equal what we get when we multiply this. We get 850 times 1.025, and that's 871.25, and so those two are not equal, so J is incorrect. That's why G is the correct answer. So it says scientists are studying a bacteria sample. The function f of x equals 245 times 1.12 to the x gives the number of bacteria in the sample at the end of x days. So here's our equation. Once again, it's in a times b to the x form. So we know that 245 is the initial value, and 1.12 to the x, that is the growth rate. It's bigger than 1, so it's going to be growth. So F says the initial number of bacteria is 12, which is incorrect because it's 245. Bacteria decreases at the rate of 88% is incorrect because this is a growth function, not a decay function. Bacteria increases at the rate of 12% each day. Well, let's check that. So that would mean that B equals 1 plus 0.12. Remember, we move the decimal to the left twice, and that is 1.12, which does match our equation. And then J says the number of bacteria at the end of 1 day is 245. So let's check if that's correct. So that would mean that we have 245 when we plug into our equation, and x is 1. So this means that 245 equals 245 times 1.12, and 245 does not equal 274.4, so that is incorrect. So H is the correct answer. So a student uses f of x equals 5.00 times 1.012 to the x to show how the balance in a savings account will increase over time. What does the 5.00 represent? So remember, when we have equations in the form a times b to the x, a is the initial value, and in this case, our value of a is 5.00. So that's our initial value. So it says, is it the interest the savings account earned for the first year? No, it doesn't. The annual interest rate, that's incorrect because the interest rate would be related to the growth rate. The number of years the savings earned interest, that's incorrect because the number of years is the value of x. The starting balance of the savings account is correct because that's our initial value. So this gives us a graph. It says the number of game consoles sold in millions since 2009. Based on this information, which function best models the number of games sold in millions x years since 2009? So remember, when we write our function y equals a times b to the x form, we're going to first look for the starting value. So this starts off at 25.5. So I have y equals 25.5 times b to the x. So now to solve for the value of b, I just pick this other point on my graph. So this point 1, 15.3 represents an x and a y value I can plug in. So I get 15.3 equals 25.5 times b to the 1. So 15.3 equals 25.5 b. So now I can divide both sides by 25.5 to get 0.6 equals b. So my equation is going to be the starting value 25.5 times 0.6 to the x, which is answer choice B. So this gives me a table, and it says it represents the point of the graph of an exponential function, and it asks me to find the function. So this is one, when I have this table of values like this, it doesn't give me a starting value. What I can do is I can enter this into L1 and L2. So I'm going to use my calculator. I'm going to go to Stat, Edit, and then I'm going to enter these numbers into L1 and L2. And then once you've done that, you're going to click Stat and then arrow over to Calculate. And then you're going to choose option 0, which is exponential regression, and then hit Enter. And it should say y equals a times b to the x, and then it says a equals 16 and b equals 1.5. So that will give you answer choice F. Remember that 1.5 is 3 over 2. If you don't remember how to convert this to a fraction, you can enter 1.5 on your calculator, and then you can choose the math button, and then hit Enter when it says arrow to fraction, and it'll convert it to a fraction for you. So if you hit Enter on that arrow to fraction, it'll say that it equals 3 over 2. So this gives me a function, and once again, it's asking me to write the equation. So remember to always look for the starting value. So we have y equals a times b to the x. So this equation is going to start off at 6, so I have 6 times b to the x. So I'm going to choose this next point right here, this point 1, 2, and plug that in for x and y to solve for the value of b. So I get 2 equals 6 times b to the 1. So this gives me 2 equals 6b. So if I divide both sides by 6, I get 1/3 equals b. So my equation is going to be y equals 6 times 1/3 to the x, which is answer choice A. So this once again gives me a table of values and asks me to write the exponential function. So I'm going to go back to my calculator. I'm going to enter this into L1 and L2. So remember, you go to Stat, and then you hit Enter on Edit, and you enter these numbers into L1 and L2. Then once you've done that, you're going to click Stat, and then you're going to arrow to Calculate, and you're going to choose option 0, which is exponential regression, and then hit Enter. So this should give you, it should say y equals a times b to the x, and it says a equals 18 and b equals 1.2. So I know that a equals 18 and b equals 1.2. If you need to convert 1.2 to a fraction, remember you can hit type in 1.2, then hit math, and then hit enter on arrow to fraction, and it'll convert it to a fraction for you. So that'll give you 6/5. So the answer choice is B, 18 times 6/5 to the x. So this says there are 1,024 players in a tennis tournament. In each round, half the players are eliminated. Which function can be used to find the number of players remaining at the end of x rounds? So remember, we have our equation y equals a times b to the x. Because I don't have any percentages, I can use this form. So my initial value is 1024. I start off with 1024, and then I'm eliminating half. So half is 1/2, so 1/2 every time. Or in this case, it asks you to write it as a decimal, so I'm going to be multiplying by 0.5 to the x. Because that's an exponential decay function, so this number should be less than 1. So this problem says that in the year 1900, the total number of metric tons of copper produced was 495,000. Each year since 1900, the total number of metric tons of copper produced has increased by about 3.25% over the amount produced the previous year. Which function models the total number of metric tons of copper produced in the year that is X years since 1900? So once again, here's your big red flag. You have that percentage. Okay, so my equation is going to be y equals a times 1 plus or minus r to the x. Well, here it says increased. So I know that my equation is going to be a times 1 plus r to the x. Because if it's increased, that's going to be a plus sign. So now to find r, I need to take this 3.25% and convert it to a decimal. So remember, I have to move this to the left twice. So r equals 0.0325. So when I write my equation, I get y equals a, which is the starting value of 495,000, times 1 plus 0.0325 to the x. So that's y equals 495,000 times 1.0325 to the x, which is answer choice A. So this question tells me that a particular type of cell doubles in number every time. So it's doubling, so it's being multiplied by 2. Which function can be used to find the number of cells present at the end of h hours if there are initially 4 of these cells? So I have to go back to my equation, y equals a times b to the x. So remember, a is our initial value, so that is going to be 4. B is our rate. So the rate of change is going to be 2 since I'm doubling every hour. So this is going to be 2 to the x. But in this case, it wants us to use n and h. So it's going to be n equals 4 times 2 to the h, which is answer choice B. So here it says the amount of fertilizer in a landscaping company's warehouses decreases at a rate of 3% per week. The amount of fertilizer in the warehouse was originally 78,000 cubic yards. Which function models the amount of fertilizer in cubic yards left after W weeks? So here's my red flag. Here's my percentage sign. So I know that my equation is going to be a times 1 plus or minus r to the x. It says decreases, so I know I'm going to have y equals a times 1 minus r to the x. So now I need to find the value of r. R is 3%. So I need to move the decimal to the left twice to change it to a decimal. So it's going to be 0.03. So I have y equals 78,000, which is my starting value, times 1 minus 0.03 to the x. So this is going to be y equals 78,000 times 1 minus 0.03 is 0.97. So this is 0.97 to the x. So in this problem, it says a toy is made up of cylindrical rings stacked on a base as shown in the diagram. The diameter of ring 1 is 87% of the diameter of the base. So in this case, the diameter is getting multiplied by 87% every time. So the rate of change, B, is 0.87 because that's what's getting multiplied by the diameter every time. For rings 2 through 7, the diameter is 87% of the diameter of the ring directly below it. So the diameter of the base is 5 inches. So this gives us a starting value because we start at the base and then it decreases as it goes up. So A is going to be 5. So if we write our equation in A times B to the x form, we get y equals 5 times 0.87 to the x, which is answer choice F. So this gives us a table of values of an exponential function. So you can do this one of two ways. You can do this by entering into L1 and L2. But the unique thing here is they give us a starting value. They give us the value of x equals 0. So we know that this equation is going to be something y equals 0.0625 times b to the x. So actually, it kind of leads us to this answer choice H. But you can double check by entering this into L1 and L2. So remember, you're going to go to Stat and then choose Edit and enter into L1 and L2. And then click Stat. Once you've done that, click Stat, arrow to calculate, and choose option 0, which is exponential regression. And that will give you this equation, q of x equals 0.0625 times 4 to the x.